Yes.
Okay, I just need to know if I'm doing this right.
Sure.
So I have this question about the ambulance service.
There. Oh,
that
good.
has
There you go.
the circle and then the rows in between it, and I circled
Right.
that on the decimals. And then it has this point and this point.
Right.
And then I just put it in the distance from that.
That's it. Yep.
Okay.
That's it. You got it. Very good. Good job. I thought that was kind of a tricky one myself. Okay, let's have a quick look. I just want to show you there's one I didn't get through. If you feel like you got this, just ignore me and keep working. But if you don't, have a look. We want to fit, this is one where we want to fit the quadratic function in general form, to general form for the parabola that passes through those 3 points. Right, so we know if it's passing through those 3 points, I think this is the one thing we didn't get through completely. We kind of got cut off at the end. So what's this really mean then? So it gives us some solutions to the function y equals ax squared plus bx plus c, right? Now because we're gonna put this into, really what we're gonna do is we're just gonna plug in values of x and y and get 3 separate equations in the unknowns a, b, and c, right? When we plug in values for x and y. So I'm actually gonna migrate the y over to the other side and write this as ax squared plus bx plus c equals y. So what do we get from the point, we'll just kind of color code these. What do we get from this first point then? If I plug in -4 for x, isn't that going to give me a times -4 squared? Well, what's -4 squared? 16. So that's going to give me a 16a plus b times -4 is minus 4b, right? Plus c equals 14. That's what the blue point is giving me if I plug the blue point into that equation, right? Okay, what about, we'll make this the red point. If I'm plugging in -2 for x, so then I'm going to get a times -2 squared is 4a, plus b times -2 is just -2b, plus c equals my y value, which is 6, right? And then finally, if I make that the green point, if I plug in -3, I'm going to get a times -3 squared is 9a, and then b times -3 is -3b plus c equals 9. So there is my 3 by 3 linear system written as a 3 by 4 matrix, right? So now all I have to do to solve this is either, has anybody done the matrix stuff in Desmos? Is it pretty easy to do? Yeah, I mean, if you want it, I haven't done it yet, but I would assume it's pretty simple. You're welcome to use either Desmos on the test or your graphic calculator or both. I don't care. And so then all I would do is just go second matrix, edit matrix A. It's already a 3 by 4, and just fit this thing. You know, just plug in the values. So what first row is going to be what? 16, enter, -4, enter, 1, enter, 13, etc. I'll just throw this in real quick. So the next one would be 4, -2, 1, 6, and then finally 9, -3, 1, and 9. Okay, and then once I've got all those in there, I'm just going to go quit, and then second matrix, math menu, scoot up from the bottom to B. I can just go alpha B if I wanted, shortcut. Plug in matrix A, the matrix that I built, close parentheses, hit enter, and there are my answers, right? A is 1, B is 2, C is 6. So I would just write that out in standard form. So my answer would look like then what did we get here? So we'd end up with, what were, you remember what those were again? I forgot. The values, here, put that. So we had 1, 2, and 6 for A, B, and C. So we're going to fill in the blanks. So f of x equals 1x squared, so just x squared. B is 2, so plus 2x plus c, and c is 6. So that'd be my answer. Okay, there is a quick little shortcut. I wasn't really planning on showing you this, but Elton figured this out. So if you want to kind of legally cheat on this, the other thing you can do for this problem is if you go to the regression stuff, if you go stat, edit, and if you just put in those 3 points and do quadratic regression, you'll notice that 3 points defines a parabola, right? And so if we go, like, I'll go up the top and clear that column. Oops, clear. Now watch how easy this is. If I just put in the points, well, no, never mind. Yep.